All right, now let's shift some exponential functions around. These are a little feistier because they have that whole asymptote thing going on. All right, so we are going to say that this parent function is e of x. That's what we're going to name it, and e of x is going to be 2 to the x. So that's our original function. What is the equation for the asymptote of this graph? Well, remember that this graph is leveling off here. It's going to get very close to, but never touch 0. So the equation for that is y equals 0. The domain of e of x, there is no number that I cannot put in an exponent. I can raise 2 to the negative numbers, I can raise 2 to the positive numbers, I can raise 2 to the square root of 2 if I want to. There's no restriction on this, and you can see that in this graph, how the arrows go all the way that way and all the way that way. So I don't have any problems in my domain. So my domain is negative infinity to infinity. The range is going to go from bottom to top. It is going to get very close to, it's going to really approach this 0, but it's never going to include that 0. So we're going to say it goes from 0 up to infinity. All right, this is our parent function. Now let's mess with it. Here's our new function d of x, and it is going to be made by transforming or translating e of x. All right, so the two things that I have done to e of x is on the outside here, I have moved it all the y values up 2. All right, it's happening on the outside, it happens just like you think. On the inside, I'm taking all the x values and moving them left 3. There are two main features of an exponential function. There are its asymptote and its y-intercept. The rest of it is kind of just schwumpy. There are a few specific points that you can note, but a lot of it is fractions. All right, so I'm going to translate this exponential by messing with the asymptote and then this y-intercept. So first off, the asymptote, it doesn't change if I move it left or right, but it does change if I move it up 2. So my new asymptote is up 2 from my old one. Now this 0.01 on my original function, that both of these transformations are going to apply to that 0,1. So I'm going to move this point up 2, and I'm going to move it left 3. And it's going to end up right there. So I'm moving it up 2, left 3, and now my new point is right there. If I have this other point right here, an easy point to translate, I can move this point up 2 and over 3 on my parent function. All right, so on the original parent function, it was at 2, 4, 2, 4, and then I'm going to move it up 2 over 3, and I end up with my new point being negative 1, 6. So you can kind of see the new schwump right here. It goes through that first point, through that second point, and carries on. Okay, so that's how I'm going to mess with this exponential function. Move the asymptote and then translate any points that I find. Let's do another one. C of x is 2 to the x minus 2 minus 1. So now instead of function notation, it's giving me an equation. It's giving me equation notation. So I have to note what is on the inside and what is on the outside of this equation. On the outside is this minus 1, which means that I'm going to move everything down 1. On the inside, the thing squished in with the x, and in an exponential function, it's squished into the exponent, is a minus 2. All right, which means that's going to affect the input. It's the input minus 2. It's the opposite of what you would think. That means I move all my x's to the right 2. Another way you would write c of x, all right, is e the x minus 2 minus 1. They're just taking these transformations that we've looked at and physically putting them into an equation. That's how it would look in the equation. Okay. So let's sketch our new asymptote. The old one was here at 0. The new one is going to be moved down 1. Okay. And then let's look at this point 0, 1. I'm going to move it down 1 and to the right 2, which means that it's going to end right there at 2, 0. I'm going to use this other helper point of 2, 4 again. I'm going to move that down 1 and to the right 2. So 2, 4, I'm going to go down 1 to the right 2, and I end up there at 4, 3. So now I have this schwump. It's going to hug my new asymptote, come up through that first point, through that second point, and then rise pretty quickly. It's an exponential function. All right. The domain of this exponential function is negative infinity to infinity. The domain hasn't changed. The range, though, has moved down 1 from our original range. So instead of going from 0 to infinity, this is now approaching negative 1. But no matter what the asymptote is, we never include it. We never include it. It is not included. All right. This is the exact same problem. Let's skip it. Isn't it fun that I have it twice? All right. So now let's look at b of x, and we are interested in the domain and the range of b of x. What are the two transformations that are happening? On the outside, I have minus 18. It's on the outside, so it is going up or down, in this case down, 18. On the inside, I have a plus 7. Because it's on the inside affecting the input, it's going to go opposite of what we think. It's going to go left 7. So my domain, if I move this original parent function left or right, nothing really changes. My domain is still going to be negative infinity to infinity. Moving it left or right does not change that fact. The minus 18, though, the moving it down 18, is going to take it from this asymptote. My new asymptote would be at minus 18. So my new range is going to, instead of approaching 0, it's going to approach negative 18, and it's going to still go up to infinity.